Hello students, welcome back to maths class. So from this topic I said two long questions. From the first two exercises, one long question. From the last exercise, that means totally we are having three exercises in this pair of straight lines. From the first two you can expect one question. From the last one exercise, compulsory one question, right? So two long questions are there. So only we will concentrate on long questions from this topic. No need to do any other problems. Why means from blueprint it is given that from pair of straight lines we are going to get two long questions. Okay. So be perfect with this topic so that you can score 14 marks in final paper. You can answer two long questions, means 14 marks you can answer from this topic. So important topic, little bit lengthy, but slowly you will get used to this same concept. We will use concept means here pair of straight lines means we will write combination of two straight lines we will write, right? After that we will multiply and we will equate the coefficients of like terms on both sides. Okay, so that will be common for all the problems. Now come to this 7 marks question. So what is this? Again it is show that like your previous we proved one theorem, isn't it? Theorem and show that, prove that problems, we will know the answer, isn't it? So this is show that problem. What is that? Show that the product of perpendicular distances from a point alpha comma beta to the straight line ax square plus 2hxy plus by square is equal to 0 is this one. Okay, so product means multiplication. Read the question once again. Show that the product of perpendicular distances from a point to the straight lines. So this is a combination of two straight lines, pair of straight lines. You know it very well, isn't it? So to those two lines from that point P alpha comma beta, if we take the perpendicular distance, their product must be equals to this one. Product of perpendicular distances from a point to these two lines must be equals to this one. This is what we have to prove. That means you know the answer of the question. Okay, so that means we have to find the perpendicular distance from P alpha comma beta to first line OA, and next the perpendicular distance P alpha comma beta to second line. What is second line? OB. OB means L2x plus M2y is equal to 0. Okay, so come on, we will solve the problem. So let, what is the equation? Ax square plus 2hxy plus by square is equal to 0 represents a pair of straight line. So whenever it represents pair of straight lines, we will write combination of two line OA and OB, just like our previous theorem. Okay, so we can write this as ax square plus 2hxy plus by square is equal to, come on, how we will write? The combination of L1x plus M1y into L2x plus M2y. Okay, so now first with L1x you multiply these two, next with M1y you multiply these two. So come on, L1x into L2x, L1 L2x into x square, next L1 M2, right, xy. So with this over, now with this it is M1 L2, right, xy. Okay, next it is M1 M2 y square, M1 M2 y into y square. Okay, so now if you observe, this is xy term, this is also xy term. Write xy terms together. Okay, so L1 L2 x square plus, if we take xy common inside the brackets, L1 M2 plus L2 M1 into xy plus M1 M2 y square. What is this? This is nothing but your ax square plus 2hxy plus by square. isn't it? So now compare the coefficients of like terms on both sides. X square term is there, x square term is there, xy term is there, xy term is there, y square term is there, y square term is there, isn't it? So comparing the coefficients of like terms on both sides. Why we should compare? In the middle is equal to is there, that's why we can compare, we can equate the coefficients of like terms on both sides. Then what happens? Your L1, L2 x square coefficient is equals to A, and xy coefficient, what is that? L1 M2 plus L2 M1 is equal to 2H, right? And your M1 M2, right? What is that value? Y square coefficient. Here y square coefficient is B. So we got our A, B, C values. Okay. Now what is the given question to us? The perpendicular distances from the point to these lines. So first you take D1 is equal to perpendicular distance from that point. Which point? P alpha comma beta to first line. What is your first line? Your first line is OA, right? That is L1x plus M1y is equal to 0. So you know the perpendicular distance formula by our straight lines, isn't it? What I said? The perpendicular distance, suppose this is the line, okay, AX plus BY plus C is equal to 0. Here is the point X0, Y0. Then this is our perpendicular distance from this point to this line. This is the D. So what is your D formula by our straight lines, right? It is AX0 plus BY0 plus C by root of A square plus B square, isn't it? Already we did this in our straight lines. Okay. So here also instead of x0, y0, the point is alpha comma beta. Instead of ax plus by plus c is equal to 0, we are having L1x plus M1y is equal to 0. Come on, apply that formula. It is L1 in x place alpha plus next b place we are having M1 and the point is beta by root of, come on, L1 square plus M1 square. Okay. Similarly, you take your D2. What is your D2? D2 is equal to perpendicular distance, right? From which point? From same point P alpha comma beta to second line OB. What is your OB? L2x plus M2y is equal to 0. Applying same straight line formula. So no need to write 2 times, right? So here we have taken. So come on, how we will take? Modulus of L2 alpha plus M2 beta, okay, by root of L2 square plus M2 square. Okay. So question is the product of the perpendicular distances from the point to these lines must be equals to this one. We have to prove that the product of the perpendicular distances, right, from the point P alpha comma beta to these pair of lines is equals to that one. Product means multiplication. Come on, take the product now. Product of perpendicular distances, that is D1 into D2. What is your D1? D1 is equal to modulus of L1 alpha plus M1 beta by root of L1 square plus M1 square into modulus of L2 alpha plus M2 beta by root of, come on, L2 square plus m2 square. Okay, so suppose we are having mod A into mod B, we can write modulus of A into B. Okay, so same thing here, modulus of first line into second line. So we can write combinedly L1 alpha plus M1 beta into L2 alpha plus M2 beta. Okay, by downwards, if both are having same root, isn't it? We can take root A into root B as root of A into B. If power is same, we can take combined linear product. So here we will take this as root of, come on, L1 square plus M1 square into L2 square plus M2 square. Okay, so come on, now we have to multiply these two values, upward values. First with L1 alpha, these two values you have to multiply. So L1, L2, alpha into alpha, alpha square plus L1, M2, alpha, beta. Come on, next it is observe M1, L2, alpha, beta plus last one M1, M2, beta into beta, beta square. M1, M2, beta square, for that modulus is there. Okay, by root of, same thing downwards also we have to multiply. First with L1 square you multiply these two, next with M1 square you multiply these two values. So come on, L1 square, L2 square plus L1 square, M2 square. Next with M1 square, these two values you have to multiply. M1 square, L2 square, M1 square, M2 square. Okay, so whenever square power is same for the product, we can take that combinedly. Okay, so and observe here, here alpha beta is there, here alpha beta is there. We can write combinedly that term. So it is L1, L2 alpha square plus, come on, alpha beta can be taken common. So L1 M2 plus L2 M1 into alpha beta plus M1 M2 beta square. Okay, I have taken combinedly, common, alpha beta as common, and downwards observe in a product power is same, we can write combinedly. So L1 L2 whole square plus first and last we have to take M1 M2 whole square. Okay, plus this can be written as L1 M2 whole square plus L2 M1 whole square. Okay, so is equal to modulus of L1 L2. So after comparing we got L1 L2 as A. So A alpha square plus, come on, L1 M2 plus L2 M1 value is 2H. So it is 2H alpha beta plus M1 M2 is B small b, B beta square by downwards which value we have to get. Observe, this is a show that problem, you know the answer. So according to the answer we have to take the question. So A minus B whole square we should get A minus B whole square, where A is L1 L2, right, B is M1 M2, right. So L1 L2 minus M1 M2 whole square form we want. So to get that one we need L1 L2 whole square plus M1 M2 whole square minus 2 L1 L2 M1 M2, that is needed, it is not there inside the root. That's why we will subtract and we will add that value. So L1 L2 whole square plus M1 M2 whole square minus 2 L1 L2 M1 M2. It is subtracted and added. It should be balanced, isn't it? L1 L2 M1 M2 plus the remaining terms L1 M2 whole square plus L2 M1 whole square. Okay, so next we can write from here to here. If you observe, this is of the form a square plus b square minus 2ab form, formula form. So in place of that we can write a minus b whole square. That means this minus this whole square. Okay, so is equal to, it is modulus of a alpha square 2h alpha beta plus b beta square by root of, come on, how we can write? L1 L2 minus M1 M2 whole square. And now here we will write this term as L1 M2 whole square plus L2 M1 whole square plus 2 into here multiplication. We can change the places, right? How we can change the places? L1 M2 into L2 M1. Okay, now observe this one. Suppose if we consider this as A, this as B, it is of the form A square plus B square plus 2AB. That means A plus B whole square form. So we can write this as modulus of A alpha square plus 2H alpha beta plus B beta square by root of, come on, here this is your A, so A minus B whole square plus this one is L1 M2 plus L2 M1 whole square. So what is that value? L1 M2 plus L2 M1. After the comparison we got that value as 2H. So 2H square. Okay, so is equal to modulus of A alpha square 2H alpha beta plus B beta square by root of, come on, it is A minus B whole square plus 2H whole square. 2H whole square means 2 square means 4H square. So is equal to A alpha square plus 2H alpha beta plus B beta square modulus by root of, what is this value? A minus B whole square plus 4H square. Okay, so hence proved. We got the product of the perpendicular distances is equal to this one. Okay, so show that problem. So you have to write hence proved. Okay, so whenever it is show that, prove that, you have to write hence proved. So what is the procedure? Actually your previous theorem and this will be little bit similar. Where it is similar, first we have taken the pair of lines as combination of two lines, right? After that we multiplied and comparing to get our A, B to H values, right? Then D1 is the perpendicular distance from P alpha comma beta to L1x plus M1y is equal to 0, right? Which formula we applied here? Since the perpendicular distance is equal to modulus of Ax naught plus By naught plus C by root of A square plus B square. From straight lines, right? We applied this perpendicular distance formula. Okay, this D1 is the perpendicular distance from the point to first line and D2 is the perpendicular distance from this point to second line. Okay, by using this formula we got this one. Okay, so next you take product of these perpendicular distances D1 into D2. Product means multiplication and mod A into mod B is mod AB. And similarly downwards, root a into root b can be taken as root a into b. Here modulus of a into b. Upwards, downwards, it is root of a into b. Now we multiplied this into this. Similarly downwards, first with L1 square these two, next with M1 square these two. If we observe, we are having two alpha beta terms, alpha into beta terms. So you take alpha beta common, inside you will get it. Okay, and downwards, whenever in a product power is same, we can take that power combinedly. L1 square into L2 square can be taken as L1 L2 whole square. Okay, so after that in L1 L2 place, we know it, right? After multiplication of these two line equations and comparing the coefficients of like terms, we got L1 L2 is equal to A and 2H is equal to L1 M2 plus L2 M1, and B value is M1 M2. We substituted all the values there. Okay, and downwards if we observe, L1 L2 whole square, I have taken first term and last term together first. After that I have taken these two terms after taking these two values. We divided the values into two parts, right? Why we are doing like that? To get our answer. What is our answer? It is root of a minus b whole square, right? Plus 4h square we have to get. So a minus b whole square means a is L1 L2 and b is M1 M2. We must get L1 L2 minus M1 M2 whole square. For that L1 L2 whole square plus M1 M2 whole square minus 2 L1 L2 M1 M2, a minus b whole square form. So to get that one, it is subtracted and added. Okay, so after that I adjusted these values. How we adjusted? If you observe, this is a square plus b square form, 2ab it should be. So in a multiplication we can change the places of the values. So I have taken L1 M2, L2 M1. Okay, so there we can take, again it is of the form, in the formula form, a square plus b square plus 2ab, so a plus b whole square form. This is your 2h, so I substituted 2h whole square is 4h square. You got your answer. So in the show that problem and prove that problem, finally you have to write hence proved. Okay, so practice this one. This is also most repeated 7 marks question for the board exam. Okay, that's all for today. Have a nice day.